start over. So, good afternoon, everyone. My name is Jonathan Penhouse, and I'm working with Dr. Niels Manis on the post-harvest extraction of pecan oil. So, the reason this is a key interest of our study is because tocopherols and squalene have antioxidant properties, particularly gamma tocopherol. It's specific in wound healing with emphasis on diabetics, and squalene is integument UV protection. So, the data that we get from this study will be used for another study in Tulsa with rats that will be testing the actual properties, whether pecan oil has a sufficient number or a high content of gamma tocopherol and squalene, that they're able to see these two results if there's wound healing and if it helps with UV protection. So this week I worked on HPLC and optimization of the saponification process. So saponification is a process where we take a fat or an oil and it's converted into a soap or alcohol by means of an alkalinic solution. Or alkalinic chemical. So we use KOH. KOH is potassium hydroxide. And in this first picture, this is about 70 milligrams of the oil that we extracted last week. And it's combined with ethanol and ethanolic pyrogallol. Ethanol acts as a solubilizer of the oil, making it more soluble since oil is hydrophobic and KOH is hydrophilic. We want to be able to have that be completely suspended uniformly. And ethanolic pyrogallol acts as an oxygen absorber. It prevents oxidation of the tocopherols and squalene since they are antioxidants. So in the next picture, this is the heating block. Prior to this, we added KOH, and this is testing for different times where we can see where there's a maximum recovery between 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, and 6 hour. So afterwards, after it's finished in the heating block, we're going to add DI water. DI water acts as it increases the hydrophilicity of the solution, so we can have that clear separation between the KOH and then when we add hexane ethyl acetate, so we can have a separation between the two. So if we don't add DI water, it will take a little longer to separate between the two. So, yep. So in this image, this is where we are adding the hexane ethyl acetate, and then we will vortex it with the KOH. That will maximize the contact between everything in the vial. So afterwards, we'll let it settle. Then we'll decant the upper solvent layer, which is the hexane ethyl acetate with the tocopherols and squalene in it, and we'll put it into a separate vial. So that will repeat 3 times. And then the final part never mind. And then in this picture, we take our solvent layers that we combined, the hexane ethyl acetate, and we'll put it into a centrifuge with a vacuum. This will be centrifuged overnight until the hexane has completely evaporated. Afterwards, we'll reconstitute it with 950 microliters of methanol and 50 microliters of a 2 milligram per mil alpha tocopherol dilution. Alpha tocopherol acetate is our internal standard, and that will be used to calculate the content of the analytes within the run. So in this image, this is a picture of the program. This is the schedule. We use Chromeleon, that's the software, and I had to insert all the different samples, and we had to have duplicates, and that'll be run with the auto sampler. And then this is a picture of the chromatograms, and it's an overlay comparing the hexane with the chloroform methanol during the oil extraction. The line on the bottom is the hexane, and the one on the top is chloroform methanol. The chloroform methanol, there wasn't a significant difference between the squalene. However, for gamma tocopherol, there was noticeably a higher peak for chloroform methanol compared to hexane. So when in the calculations, there was a higher content per milligram of oil, or of gamma tocopherol from the chloroformethanol compared to the hexane. And then next week we will be working with maybe other years of the same cultivar. This is Kanza. And then we'll be extracting oil from those and then maybe looking into other cultivars. So that's what we did this week. So do you have any questions? Thank you.